Hi there. I recently worked on this component, the INA236. Great current sensor, no problem there. But yeah, it got a configuration aspect to it where you need to set up a bunch of registers, including that one, the configuration register, which is a 16-bit wide register. All fine. And if we look at those bytes and bits in particular, we got 16 bits. The first three ones are going to be used for the mode 0, 1, 2. Then the next three ones are going to be the VSHCT 3, 4, and 5. And finally, the 6, 7, 8 are going to be used for the VBusCT. So the 6th, the 7th, and the 8th. So we got a field that is straddling between 2 bytes. And that turns out to cause problem for some compilers, GCC in particular, GCC over ARM, and I can reproduce it here on GCC for my laptop. So let's have a look, let's run it, let's see the problem, and let's discuss a few solutions. So first of all, how is it implemented? Well, I got my my type def union with a bit field that is matching each and every one of the fields inside of our configuration, VSHCT and so on, and the other one, but it's not very important here. And so what we can see is that we got 3 bits for our mode, then 3 bits for VSHCT, and then 3 bits for VBusCT. So in total, we get 9 bits used for those 3 fields, so one more than 1 byte. Great, we got that union that is going to make sure the 16-bit of the config are going to be overlapping, matching in memory with our struct and our bit fields. That way we can access it in 2 ways, either through the bit fields themselves to set up the configuration and have software that is readable, and we can also access it through that config variable, so that we can take the entire field, the entire registry, and just send it over I2C or whatever protocol. All that is in a type def so that it's easy to use. To make it even cleaner, each one of those fields are actually a type def on its own. So for example, that one, the mode, got the different modes that are matching with the values, the biggest one being 111, so the value of 7 for continuous mode, whatever. Now, how is that actually implemented in main? How do we use it? Well, it looks like that. I'm going to have an enum here that is just one of the enum from the field, so that we can see how big it is. This one is 0, 1, so the question is, how many bytes is it going to take in memory? What we do, we instantiate it, we don't even set the value, and we just show the size of that variable to see how much memory it takes. We're going to do the same thing with the configuration, which this one is our entire configuration, 2 bytes wide or 16 bits of configuration. We're going to, with the first printf, we're going to see how big it is. And then with the third one, the last one, we're going to actually show the value of it, the full value in hexadecimal. What value do we expect in that case? We start by setting to 0 the config here, which is that 16-bit value, so that we can erase and make sure everything is at 0 to get started with. And we're going to put the mode to the highest value possible, 7. So those 3 bits at the bottom are going to be all ones. We're going to do the same thing with the VSHCT, putting it at 7. And finally, the VBusCT, we're going to put it at 7 too, so that we get only ones. How is it supposed to look in binary? Well, here it is. It should be the 3 ones for the modes, followed by the 3 ones for the VSHCT, followed by the 3 ones for our VBusCT. So that's a value of 1FF. Let's run it. Let's see. Here, what I'm doing, I'm just cleaning the project, making it, and then running the result. What do we get? Cleaned everything, built everything, linked everything, and then we get back in the main. We're going to get our first thing is going to be the size of our enum, one of the enum, which is over 1 byte. That enum had only two possible values, 0 or 1. It takes 1 byte in memory. Everything looks fine. Then we're going to look at our configuration, the size of our configuration. There we get 4 bytes. That's more than expected. We only got 16 bits that are useful. Why do we get 4 associated to it? That's weird. And if we look at the value, we start having an idea of why it's taking 4 bytes. We get the value of 0x73f, which is not what we're expecting. And if we have a look at what 73f means in binary, we can see that we got 3 ones for the mode, perfectly fine. We got 3 ones for the VSHCT, perfectly fine. And what we can see is that the compiler decided that, yeah, no, those ones, I'm just going to put 2 zeros of padding, and your VBusCT is going to be moved to the next byte, which makes my configuration not work, and the component does not understand what I want. So that's annoying. Let's see how we can solve that. So first solution is to actually just write the value directly in the config. That works. Yeah, we are still using that structure. So when we actually run it, we're gonna get 4 bytes for the size of our structure, but we are actually getting the right value, 1FF, like expected. It works in the microcontroller. It doesn't work for a human. That thing is unreadable. I have no idea what 1FF means, so I don't like it. But at least it works. That's a little bit of progress. Okay, second solution. We are back with our enums. At least our code is readable. That's a good start for humans, but let's try to solve the problems on the machine side. If we look at here, what we get was actually a padding issue, and usually you get those padding issues when you got a mismatch between the size of your different variables. So what if we try to make things all align on 16 bits? And we're going to focus, for example, here on our VBusCT, which is going to be the one that is straddling over the 2 bytes. So that should be the one that is generating problems. And if here we implement all the values that are interesting between 0 and 7, and we add a new one that is suspiciously above 256 to force that enum to be interpreted as a 2 byte value, up to 2 byte value. Let's build it and let's see what it does. There, what does it do? It builds with a warning complaining about the fact that we are using it in our type-def union, and the fact that we allow only 3 bits for a value that could go up to 65,000. So yeah, that's fair enough. That could be a problem. Hopefully we are not supposed to use that value, but that creates a warning. And as you could imagine, it's gonna, if you do it for every one of your enums, it's gonna create you 1 warning per enum all across your project. That's not really clean. But at least we can look at the size of, here in the main, we are looking at the size of our enum, of our VBusCT. We can see that it takes 2 bytes, as expected, values up to 65,000, need 2 bytes for that. But our configuration now, it's matching. Now we are over 2 bytes. Now we are getting what we want, and the value is 1FF. So we're making progress. The solution isn't really clean, even the compiler is complaining about it with a warning, but at least we got the values that we want, and we're taking the expected amount of memory that we were thinking about for 16-bit field registry. Let's have a look if we can improve that. Third solution, we remove that 65,000 value. We keep our enums clean as they were before. In our main, we don't touch anything. We want that to be readable, so let's not touch that. What we can do is we can indicate to the compiler that you should maybe try to, cram as much data as possible into that structure, and don't try to be smart with padding and so on. And by using that pragma pack, you can actually tell it to Yeah, actually, even up to that one, meaning up to 1 byte, it's okay. You can just cram data. We don't really care about alignment and easy access to the data. Just jam it in, it's fine. And as it turns out, it's going to also apply for the bits inside of the bit field. The one is for bytes inside of a bigger structure, but it also, as it turns out, applies for bits inside of our bit field. The key thing to be careful about is that we are telling it, yeah, just jam the data in it. At the end, once you've defined your structure, don't forget to put the pragma pack with nothing as an argument. That way you are resetting the behavior of the compiler to whatever it was at the beginning of the compilation. So that we are changing the behavior only locally and we are not creating problems anywhere else. That's it. So if we have a look at how it runs, we don't have a warning. First of all, that's nice. That's definitely an improvement. If we look at the size of our enum, we are back at 1 byte because we removed that 65,000 values. So back over 1 byte, it makes sense. We're not wasting memory. Our configuration is over 2 bytes and our value is 1FF as we predicted, as we wanted, as we expected. And that's it. A cleaner solution, at least from what I can see, that is the cleanest solution that I could find to force the compiler to make bit field straddle over multiple bytes. That's it. Hope you learned something. Be careful that this solution and this problem, according to CPP reference, really depends on which compiler and which target you're having. So maybe you're not going to get that problem, or maybe you will get it even with some of those trickery that I showed you today. That's all. Have fun building stuff. See you around. Bye-bye.